Good morning, everybody. My name is Sumeet Kichar. I come from Lenovo. I have a past history of being at IBM for a number of years. So bring with myself legacy of working on scaled up servers. We have 8-socket servers out there that a lot of our customers are using today. So as Mohan and others were sharing yesterday, scale up is getting important because of the memory footprint. So I think 2-socket as well, as devices are moving further and further out to the edge, it's important to look at what's the health of the device. And in this presentation, we want to go and share what we think the health should look like and what things should we be looking at. So I'm Sumeet Kichar. With me, the presentation, Theo from Intel, and Devinder from Microsoft. So we wanted to look at it. Lenovo has been doing it, and IBM back in the years. We've been doing it a lot on our own. But this is the first time since last year we said, let's look at it holistically. Let's look at it from the lens of how a customer would use it at scale. So really appreciate them in their providing us input here. So we'll dive right into it. So first slide is not from me. It's from a marketing guy. Normally, I don't pick up statements from a marketing guy, but this one I really like. No downtime is a good time. So this is one of the best lines I've seen. And it's not just dollars. It's as servers are moving, as we're talking about autonomous vehicles, servers sitting in the trunk of a car, it's life and death matter at this point. As servers move further and further out to the edge, it's important that we have reliability, security around those servers. So edge has made this thing, which used to be data center thing, even more important than before. We need to understand not just the failures. Our focus in the past has been, OK, let's look at the health of the server in terms of, is it failing, is it up and not? So we think it has to be looked at broader. The failures which are kind of not obvious because it's not giving you 100% performance in SLA as you expect, but it's not performing the way it should be. And that's where we've dug in deeper with Intel and Theo's help on. There's a lot of rich data sitting in the chipset that we can look at and get an idea of how the thing is, how the transactions are, where the deadlocks are, and look at that kind of data as well. The right data, hence, is the key. The historical data is as important as the data at the point of failure. So in this, we'll share, and this is BMC-centric proposal that we have. And BMCs are becoming more and more prevalent, especially as part of the openness of the firmware. This is something we've been doing on our own. We can drive it into open firmware and have everybody benefit from it. And we've kind of reversed the title. I think it says AtScale Debug, but it's debug at scale, essentially, because that's the way we need to look at it, not just as an interface. That's a JTAG thing. So we have our friend Alan sitting there wearing T-shirt since yesterday and advertising for us at scale. But we really wanted to look at it as debug at scale. So these are things that Lenovo has today. We have it in our enterprise server firmware. But these are things we think open firmware should adopt as a framework as well. So how do you get to some of the data? Of course, JTAG is one thing. I think that's where AtScale Debug comes in. That's the term that Intel has been using, and Asset and Arium have done it as well. So that's one piece, one path to get the data. But what does it give you? There's limitations. When you go through JTAG, you cannot get MSRs. So you have to stop the CPU to get MSRs. So we can't totally give up Pecky. Pecky is as important because when we're looking at the data, we're looking at data that's not really a failure at this point. We're just trying to sense how does the performance look? Is there latency in the pipelines? And we need to look at it. But there may be cases when the thing has hung and or crashed for some reason. Then we want to go through JTAG because it gives you a lot richer data than you can get over Pecky. So both paths are important. In Pecky, today is a wire, and we have seen some glitches every now and then when the thing is really failing because it's dependent on host system replying to the Pecky responses. That's where we think JTAG can help, but Pecky coming over as an MCTP endpoint is another good thing that Intel and other chipset vendors are talking about, and that's a good path to enable because then you have the bandwidth and the pipe to get much richer data and snapshot from the CPU, not only wait for the thing, OK, it's crashed now, I need to understand it. As you look and try to get more and more data, the bandwidth is important, MCTP over PCIe endpoint, and making chipset like that not only helps you get the data, but also gives you a path to go in-band and update devices that you cannot update today. So it's a downtime saving as well going forward as you talk about 3D Xpoint and other devices. What we as Lenovo have been driving as part of the DMTF and PMCI group And we have a co-worker of mine who leads and co-chairs that work group, has been how do we bring the other platform devices as part of that telemetry? So this is where the MCTP helps. You can go over I2C, you can go over PCIe. We recommend PCIe because then you can have asynchronous events. You don't have to worry about muxes and where the things are and how the buses are laid out. The endpoints can actually tell their health. And we use it to tightly control the thermals as well as get the event data as the link up and down, NCSI statistics and stuff like that. So a lot of rich stuff we can collect from the endpoints with this mechanism that we didn't have a visibility in the past. Again, I think it's important and why we say BMC should be the central of the world and collecting this telemetry because no error happens in isolation. Think about memory errors. It could be a temperature-related event that may be exercising the platform above the limits it can tolerate and maybe the reason of single-bit errors or something happening. So you can't look at just one thing or the other. The platform as a whole has to be looked at to understand the problem at the depth. And I think we wanted to share what kinds of data we are looking at. So Theo, if you want to share a little bit.
Okay. Thank you, Sumeet. My name is Theodros Yigzaw. I'm a platform OS architect with an Intel. So as Sumeet was explaining, this thing is going to be only as good as the kind of data that we can give it, right? And when we think about this, we break it up into two parts. The first part is failure prediction, and the second part is diagnostics. From a failure prediction perspective, if you think about it, the A and RAS availability looks different depending on what kind of lenses I'm wearing. If I'm putting on my enterprise lenses, then the purpose of the A is to keep the system up as long as possible, right? No matter what. I don't care if the performance is impacted or not. I just want to keep it up, right? But if you look at it from with the lenses of the cloud, then that's not good enough. By the time that event has happened, and if it affects my performance, then it's no good to me, right? So a good example would be link width reduction. It's a very useful feature. If you see repeated corrected errors on your links, you can go to half width. Your performance is impacted. Your bandwidth is essentially halved, but your system is up, right? And it gives you time to schedule service or whatever you need to do. But if you're a cloud vendor, you want to know about it before you go to that half width, right? So that you can take action without affecting your performance, right? So from a failure prediction perspective, you want to have some telemetry data, and this might be things like memory bandwidth, cache allocation. If you have a noisy neighbor that's stealing all your cache, for instance, you want to know about that so you could do something about it. Power control events and etc. Now, one of the exciting things about this, for me at least, is the type of things that you can discover that we don't know today. I hope this is not too soon to talk about airplanes, but one of the things that one of the difficulties they have with airline safety is single events. They can handle that. You can think about it, you can plan for it, and you have means to deal with it. But if you have a cascading event, maybe 2 events, okay, you can handle. When it gets to 3 and 4 cascading events, it gets harder and harder to predict this and know what to do about it, right? So the promise with this is if you have a rich set of data, maybe with some machine learning algorithms, you can really get into good failure prediction, and so you can avoid events before they happen. Okay. The next part is the diagnostics portion. I think there was a talk about this last year at OCP. But essentially, the biggest challenge is, and we've lived through this, something fails in a cloud environment, right? And then we get an error log, and we go in the lab, and we try to reproduce it. It doesn't happen, right? Because it happened given the set of circumstances at that place, in that environment, running a certain workload, so we can't reproduce it. The promise with this is we collect this data as it happens in the data center itself, right? We can encrypt it, ship it out, then we can study that, that log or that set of history, and we can do a much better job of diagnosing things faster with better accuracy, and then so we can deal with them faster too. Okay?
Thank you, Theo. So I think as we're trying to open this up, so this is another concept I wanted to share. So what we have been doing till date is, I think people who have worked with us, customers who have worked with us know what we call first failure data capture. So we've been collecting for the last 10 plus years in our BMC this telemetry stuff, but it has been error focused. As we grow it and as we go to a richer set of data, I think it's important that we decide what stays and is actionable by the BMC itself, and what should be surfaced up to the higher level software and it acts on it. So that's where telemetry has to decide. Not every action should be sent up to the higher level software. BMC on itself, with the help of hosts. So the way we have solved, there was a discussion, how does BMC get intelligent? So we have been shipping scripts and chipset data in a format that the BMC can understand. It doesn't need to have the chipset knowledge. The host can seed it with that information because it's a Linux environment at the end of the day. So it's just a matter of sending, okay, here's the chipset data, this is the access method for it, and it just does the raw Pecky or whatever access it needs to do. So it's a language XML based you can define, and the BMC can be made intelligent without really having to learn anything. So that's the concept we've taken. So BMC by itself can be smart enough to do certain actions, but there are other actions that you really want to send upstream. You want to have richer data set, you want to have history. Like if you're looking at power data, you're looking at performance over time, then you want telemetry snapshots and redfish and things that have defined it. It's also key that you're able to tune this data, and you are able to say, at this point, since I'm seeing this kind of information, now let me fine tune into this. So there are hundreds of performance monitor counter registers in the CPU. You don't want to look at all of them at the same time. You may want to focus on one versus the other based on another thing that you see. So that's where we believe there should be a dynamic policy that can be pushed down by the higher level software to the BMC to say, okay, now let me focus on this. This is the telemetry I'm interested in because of this other thing I'm seeing at this point. So that's the key here. Finally, as I said, I think our focus has, in the past, has been error, but there's a lot to be gleaned out of the chipset. We can see what kind of cache accesses are happening because there are performance monitor counters that tell you about that. So any abnormal activity can be detected. Intel actually has a thing that they're working on to look at this kind of stuff, have host-based stuff. But we think sitting as part of the host and looking at this stuff is intrusive. So BMC being in the picture, and now almost all servers are putting a BMC with OpenBMC on it. You can go this path and you can leverage it. We have been looking at power through the node manager and other stuff in the past. But as we said, I think the focus needs to be holistic. It cannot be just crash, cannot be just errors. It should be looking at everything. Finally, I think once you have the history at the higher level software, you can look at anomalies, right? Where do you see the things you never knew in the past, how the servers are working? You can glean on it with this finer and focused lens that you never could before. That's the whole idea of building its infrastructure. And Devinder, I'll give it to you. So this was how we as server providers, Intel as chipset designers said this could be looked at, but we want Devinder to say how could he use it at scale.
Yeah. When Sumeet approached me, then I thought it's a neat idea we can apply to cloud use models. In our world, in the cloud usages, this idea can be clearly applied in two methods, right? One is the runtime, which is biggest bang for the buck for us to really predictively analyze the telemetry data and then take some predictive actions. So as a part of that, the reliability and availability is the key for our cloud use models. So, and this method, the idea what Sumeet and Theo came up with will clearly help us to enable in terms of securely packaging the data, the telemetry data, and then offline analysis to take some decisions. And then the performance predictive analytics can be enabled through this, and customer workload. So one of the pain points in our, especially in the compute workload models, is how can we graciously migrate the customer workloads without causing any downtime to them? And this technology probably we can leverage to really predict some failures, and then without even customers noticing, we can migrate them to a new node or something like that. I think that's the very, very valuable for the cloud CSP. For that matter, any CSP would love to have this kind of capability. And then the storage workloads, the key is to really make sure that there's no data loss, right? So in terms of that, we could gather some telemetry data or some debug data, whatever. Basically, the system is pretty much open through the out-of-band, through BMC being the hub to collect all the intelligence, right? So we could leverage that in even the storage model and prevent any data loss. So in the storage use models, it's the data loss is the key for our customer workloads, right? And so this is all the biggest bang for the buck in runtime, but I call this as a peacetime. So when you transition, the node has already eventually died, and how do we really make use of this? In the cloud, it's all over the map, all over the entire world, and we have to access the node from some other part of the world through a pipe, a network pipe through the rack manager, and then to the BMC, right? So how do we really diagnose so that we don't have to ship those systems back to somewhere and then replace the FRU and all that? One of the challenges here is most often, like because of the wrong diagnostic, the node goes down, and then we try to diagnose it, and then no failure found, right? So we don't find any failures eventually, and we get back that node into production, and then again, the same problem shows up. So that's not a really efficient model in terms of debugging, right? So this technology, probably if you have more intelligence into what FRU failed, then obviously we can leverage that. And remote debug is the key for cloud CSP guys. And then the FRU identification to root cause, then and there itself, and replace the part is the most efficient and most ROI in terms of the deep servicing the nodes. Multi-tenant, this problem, hopefully it might help if you mature this technology, but typically the rack, different nodes, even in the single node, there is a multi-tenant, and you cannot predict which VM is really having a performance problem or anything like that. So definitely, if you do more intelligence gathering in performance counters and any other devices around it in the platform, we could leverage this even to solve that problem. But this is still a unsolvable problem at this point. So we have to bring down the entire node, and it can cause trouble to multi customers, right? So that's another way to look at it to really leverage that. So I thought it's a neat idea, and we could probably, many can benefit from it. So thanks for sharing in the OSF.
So call to action, I think how do we actually make it so that people can contribute and can help us out? So as I said, I think our proprietary firmware, Lenovo, has had it for a while. Certainly our focus has been more error-oriented. Now with Intel's help, we're expanding the coverage to look at more things over next generations of chipset. More and more performance counters will be available to the BMC out of band. I think what we want to do is enable this as a framework as part of the open BMC and contribute it. So the framework is there, and whoever the chipset vendor is, you could go in and then try and focus on the data sets that you're interested in. So that's our idea. I think we welcome the feedback. We welcome where you guys think we should be looking at something different in terms of maybe what should be at the BMC, what should be more at the higher level software, what is the right boundary. what things would be interested in terms of data sets that maybe we are not thinking about. It's not there. We can, certainly Intel is part of it. We can make the request to the chipset vendors to open up some of that other. It's been defined right now. The data sets that will be exposed over time. So now is the time to provide us that feedback on what data sets that you guys think, with your experience working at scale, that would be of value and that we can expose as part of this framework. So I think we're looking forward to the community showing interest in it and basically working with us on this and enhancing what we've had. Pretty focused in one direction, but now we're trying to make it multi-direction, and hopefully you'll see interest in this. Thank you all. Questions? We'll take.
Yeah.
You're the king
Hi.
of the kingdom.
I had a question. I don't know if you could flip back a couple of slides to the one that showed like analysis at the edge. I guess maybe back one more. Sorry. Yeah. So in this picture here, are there standards that exist for those arrows? So the BMC is exposing telemetry data, and also you may want to debug. So if I have a remote GDB debugger or something like that, I guess what are the standards that exist that are maybe architecture independent? I'm from ARM and care about non-x86 debugging. So just wondering like what your thoughts are on what the protocols and standards are that.
Sure. So today, the standards exist for Redfish and Patrick is in the back, so Patrick, feel free to help me, but Redfish is defining telemetry. So it's when you collect the data, the telemetry schemas are being defined. You can create reports. So if you want a snapshot as a stream, as a callback at certain interval, you can have that. There is no standard today on how you communicate with the BMC to say, I want to send this JTAG interface command. That's not there. Our intent here is you don't have to do that remotely most of the time. You want BMC to be autonomous. You want BMC to have an app that's embedded inside the BMC that can use the JTAG APIs, and because security is also a reason, right? And we want to enable BMC and make it powerful and make it decide and analyze the data that it can locally. There's no need to send the data for errors. But performance and other stuff, Redfish is defining telemetry, so you can send it across. If there's need as we go dig further into it to define an interface that, yeah, the system is hung, a certain specific telemetry, I don't know which one I want. I really want to go look, and that would be an area that we could work as part of the DMTF Redfish standards to then define, okay, if I want to debug and manually go into a system, could we define a schema that could be more generic and doesn't matter what the low-level interface is. You just define how you get to the BMC, and the platform has knowledge. If it's ARM, AMD, or whatever, how do you go underneath it? So.
Hi, I have two questions. For runtime monitoring, have you look at the robustness of the JTAG bus, having it running while the system is operating? Does it kind of take performance away from the system, or is it purely out of band? So
I'll start, and then I'll let Theo answer that as well. So as I think in this model, the reason I went back to this picture, we are saying when your runtime system is up and running, prefer Pecky to be the path. We don't prefer JTAG to be the path because we don't want to stop the CPU to collect the data, because by nature of it, you're impacting performance. So JTAG is new. We certainly haven't dig deeper into it to measure the performance yet. But Theo, I don't know if you have any comments.
No, I think I'm just going to echo what you said, right? For runtime, Pecky is really the preferred interface. The JTAG portion is much more useful for the diagnostics perspective, where you can get to a much richer set of data than you normally can.
Yeah, so my second question is about, I guess a fail time diagnosis. One of the big problem right now is when we get those scan dump, it can contain information that internally within Facebook, we believe contains sensitive user informations. And between security and debuggability, security always trumps that. So is there, in your use case, did you have to worry about that, or how do you have those discussions?
So I think I can answer that because we've been shipping the servers and with this kind of data. So our approach always is that whatever we collect is sitting in the BMC. anybody can inspect the data, our customers, before we receive it. So you can always send it to any call home point that can inspect the data. Our focus has been never have any IP addresses, any customer usernames and stuff. So our focus has not just been chipset. I don't know if your question is specifically on the chipset. It's much broader. Yeah. Correct. Correct. Yeah, so I think that's, you want to answer the encrypted scan dump, Theo?
Yeah, I'm not sure I have a good answer for that. I think the paranoia goes both ways, right? There is information in there that we don't want exposed either. So, yeah.
So we got one more question here.
I guess just a follow-up to that to emphasize the importance of security. In general, what mechanisms are you recommending or are possible to allow cloud service providers to implement policies that will protect customer data?
Yeah, so I think, as I said, telemetry is a redfish schema today. So I think we should certainly define, it's the admin user of the BMC, and assuming BMC is part of the trust model at this point, admin level BMC access allows you to set the policy. You can enable, disable any of the filters and reports that are provided by the platform. So you have that level of control. The second thing I would recommend, as I said, when this data is collected, the customer who owns it always has the ability to configure where the report is first sent. So they can inspect on it. They can decide they want to debug internally, like a CSP, like you or somebody else would have the skills to debug on their own. A regular customer may not, but everybody should have the chance to inspect it, collect it, and decide what they want to do with it. It should not be the server provider deciding it.
All right, I appreciate that comment, but that's incomplete. So I think there's a lot of work to do in this area.
Sure, I think feedbacks Ben certainly is welcome in this area.
All right, let's thank our speakers. And will you be available at 10 in the Salon 5 and 6? Okay, thanks very much. It's a great talk.
Thank you.